Welcome back to Applied Algebra. We're going to finish up Chapter 9, the Systems chapter, and we're finishing it up with some application problems. So I've chosen 3 examples to do for you. If along the way you get stuck, please let me know and I'll give you a push in the right direction. So we'll go ahead and work on the first one. We have a plumbing contractor who's going to field test 2 new pumps. One is rated at 180 gallons per hour, the other one at 250 gallons per hour. She tests one and then the other. Over a period of 6 hours, she pumps a total of 1,325 gallons. Assume that both pumps operated as rated. How long is each in operation? So the first thing you always want to do is know what you're trying to find. So I always go to the last question, or the actual question itself, and that helps me define my variables first. How long is each in operation? So I have pump 1 and I have pump 2, and I'm just going to stick with X and Y. So X is the number of hours for that pump, and then Y would be the number of hours for pump 2. Okay, so but I can tell right away that I'm dealing with time. One is rated at 180 gallons per hour and the other at 250 gallons per hour. So we'll say that pump 1 is the 180 gallon one. So I'm kind of organizing my information. And then pump 2 is 250 gallons per hour. Now the rest of the information talks about how long the 2 pumps went and how much water they pumped altogether. So they both worked for a total of 6 hours. So pump 1 worked X hours, pump 2 worked Y hours. Together they worked 6 hours. So there's my first equation. The next one deals with the fact that it pumped 1,325 gallons. So for every hour that pump 1 worked, it pumped 180 gallons. So that's 180 times X. So if it pumped 1 hour, that's 180. If it pumped 2 hours, that's 360, and so on. We're going to add to that the fact that pump Y does 250 gallons for every hour it worked. And we know it worked a total of 1,325 gallons. So the first equation is based on the hours, the second one is based on the gallons. Now at this point we have our system, and you can choose any of the methods that you've learned so far. You can graph it, you can do addition, you can do substitution. The fact that I have X's and Y's lined up, I'm going to go ahead and do addition. I need to have a variable that has the same number in the front of it, its coefficient, but has opposite sign. So I'm going to go ahead and get the X's to be the same number but opposite sign. To do that, I'm going to multiply the top one by negative 180. That way my X's will be the same. So negative 180 times X is negative 180X. Negative 180 times Y is minus 180Y. Negative 180 times 6 is negative 1,080. So they're lined up. My X's have the same number but opposite signs, so I'm ready to go. When I add these, that wipes out my X's. 250 plus a negative 180 gives me a 70 in the Y category. 1325 minus 1,080 is 245. Go ahead and divide both by 70. And I end up with that my Y worked 3.5 hours. So now I just need to know how long did pump 1 work, and together they work 6 hours, so I'm going to take the X plus Y equals 6, X plus 3.5 equals 6, minus my 3.5, so X worked a total of 2.5 hours. So how long is each in operation? Pump 1 worked 2.5 hours, and pump 2 worked 3.5 hours. Now those numbers are based on the fact that my pump 1 is the 180 and my pump 2 is the 250. Okay, second one, we're going to do very similar in the setup and in the thought process. The sum of two capacitors is 85 microfarads. The difference between them is 25 microfarads. What is the size of each capacitor? So size of each capacitor. So I have capacitor 1 and capacitor 2. We're trying to figure out what size they are. So this one is X microfarads, and I'm going to say this one is Y microfarads. Now, the equation says that there's sum, so I have to think back. What do I know about the word sum? Sum we learned way back in one of the chapters is a plus. So we know that the X plus the Y is 85. Then we have the word difference. Difference we learned was subtraction. So the difference between them is 25. Again, I see that they're lined up. And so I'm going to go ahead and do addition. Sorry, I was raised with it being elimination. So I'm going to add these together. So x plus x gives me 2x. Y minus y, the y's are out of here. 85 plus 25 gives me 110. Go ahead and divide by 2. So the X, or the first capacitor, is 55 microfarads. Now, again, it doesn't matter which one you want to do next. You can plug it into the top or the bottom. I'm going to go ahead and do the top. 55 plus Y is 85. And minus the 55. So my Y ends up being 30. So the first capacitor is 55 microfarads, and the second capacitor is 30 microfarads. Okay, the last example. A hospital has 35% saline solution on hand. How much water and how much of this solution should be used to prepare 140 milliliters of a 20% saline solution? So I have some containers that I'm going to put together, and when I get done I'm going to have the final solution. So I know I have 35% saline, and then I have water. So now remember, this is saline and this is pure water. And together when I'm done, I want to have a 20% saline solution. Now I don't know how much anything is. I just know that when I'm all said and done I have 140 milliliters. So this and this equal 140. Now the thing I have to be careful of here is I need to figure out how to write this as a saline. And it says how much water and how much of this solution should be there. So our amounts are how much of each, right? How much of the saline solution, how much water. Now when we're dealing with percentage problems, we always have to do percent times our variable. So in this situation, I would think, okay, I'm going to do percent times x, percent times y, and I'm going to end up with my final percentage. But here's the issue. This is in saline, this is in water, and this is saline. They're not talking about the same thing. Now you could say, okay, this is 0% saline. But if I multiply 0 by y, 0 times anything is 0, and it's going to wipe out the variable. So I can't do that. So instead I'm going to ask each one how much water is in each one. So how much water is in 35% saline? Well, that's 65% water. How much water is in pure water? Well, that's 100%. How much water is in 20% saline? That's 80%. Now notice each one of these has a percentage that I can do. None of them are 0. So I'm actually going to focus on how much water is in each of these. So this first one I'm going to do 0.65 times x. So we do the percentage times the amount plus the percentage times the amount. 100% as a decimal is 1. And then again, I'm going to do percentage times amount. So whenever you're doing a percentage problem, you should have one equation that does percentage amount, percentage amount, percentage amount. So this is my percentage equation. Now I'm going to have a second equation which just focuses on amount. So x plus y equals the 140 milliliters. Now I am not doubling up because this top one is dealing with percentages, the bottom one is strictly dealing with how much is in them. So here's my system. I can go ahead and deal with it however I want. Let's mix it up a little bit and let's go ahead and do substitution. So I'm going to get x by itself. So this is 140 minus x. Sorry, minus y, because I would minus y from both sides. So now I'm going to substitute this in for my x. So I have 0.65 times 140 minus y plus y equals whatever 0.8 times 140 is. So I'm going to grab my calculator because this is actually a different way than I did it originally. 0.65 times 140. So this is 91, just doing the distributive property, minus 0.65y plus y equals 0.8 times 140, and I have 112. I'm going to come way over here because I'm running out of room. So I'm going to combine like terms, which would be the y's. So I have 91 plus 0.35y equals 112. I'm going to minus the 91. So I have 0.35y equals 91. 112 minus 91 is 21. Now I'm going to go ahead and move the 0.35 by dividing it. So 21 divided by 0.35 gives me 60. So I have 60 milliliters of the y, and the y was my water. So how much water? I have 60 milliliters of water. How much of the other solution? Well, I have 140 total, so the other one must be 140 minus 60. 140 minus 60 is 80. So I have 80 milliliters of the 35% solution and 60 milliliters of the water in order to make the 140 milliliters of 20% solution. Okay, go ahead and tackle the assignment. If you have any questions, let me know, and I'll see what I can do to help. Have a good day.